So, who's heard of the XAPI project? That's good. That's a good half of you. So it goes by a few different names, which are kind of all used interchangeably, even within Citrix. What it essentially is it's a suite of tools which gives you a high-level object-oriented interface on top of a Xen host. So you have interfaces for configuring networking and storage at the host level and at the guest level, as well as networking storage. Things like HA you can configure through Xen API. There's an HTTP interface for doing this, so you can configure most of these things via XML RPC. There's also put and get URLs for things like exporting and importing VMs. And this forms a core part of the functionality XenServer gives you on top of plain Xen. And the bit of the XAPI project I'm going to be talking about is the performance data collection. So by default, there's a component called the ROD daemon, RODD. So ROD meaning round robin database, which is the standard format for collecting sample data, kind of append-only database. And so the XAPI project, RODD within the XAPI project, collects various data sources, largely from DOM0 and a few from DOM-use, and then allows them to be exported over HTTP. So when I talk about performance data, just to kind of formalize what I mean by that, firstly, it's generally numeric, so integers, floats, percentages, that kind of thing. It's something that changes regularly. It's something you want to sample every few seconds. So obvious examples would be CPU usage, network throughput, storage throughput, not things like number of virtual NICs a VM has or an IP address. And something I'm going to propose for the context of this talk is that even though we're sampling data every, say, 5 seconds, if we don't want that sampling to interfere with the performance of the host as a whole. Essentially, we don't want the collection of performance data to degrade the performance of the host. So we'd obviously like every sample, but we don't want to go crazy with locks and synchronization to make sure we get every sample. So currently, the RD daemon mainly collects things from DOM0. It collects one lone metric from guest at the moment, which is the free memory as seen by a guest. And essentially what happens is there's a guest agent which comes as part of XenServer. You can install it in your guests, and this will write the guest free memory to xenstore every 30 seconds or a minute, I think it is. And we heard a lot about how xenstore is a big performance bottleneck yesterday. This was no exception. Even this has caused boot storm issues, general steady state CPU usage issues, just with xenstore CPU usage being too great. So some improvements we've done so far over the last couple of years, really, to do with performance monitoring. So a couple of years ago, the XAPI project was literally a daemon called XAPI. This did everything. This did all the inter-host communication. So I forgot to mention earlier that actually the XAPI allows you to pool multiple Xen hosts together, and then you can share storage, you can migrate VMs around, you can have networks which span multiple hosts. So XAPI did all this, and it did a lot of host-level things as well. It did host-level networking setup, it did host-level domain management, and it did host-level data collection. So this was really too much for this one process to do, and it was, so things like performance data collection was interfering with general API response. So what we did was we took XAPI and kind of carved it up into chunks. So the host-level operations got split out into various other daemons. So the ROD daemon I've already mentioned, network daemon was host-level networking, XenOpsD was host-level domain management. And even after that was done, as I said, we were reading DOM-U free memory through xenstore. And so we were actually polling xenstore. So DOM-Us would write their free memory every minute or so, and DOM0 would, for each guest, it would poll xenstore once every 5 seconds per guest. And this was causing problems at about 150 VMs per host, which, compared to the numbers Philippe was saying, is pretty low that we're having those issues. So the obvious quick fix was to watch xenstore instead of polling. So that's given us improvements for now, but it's a quick fix really. It's not going to last forever. So what can we do to kind of fix this in a more long-term view? So xenstore, we don't want it in the data path. It's a bottleneck for bootstore, and we certainly don't want it being used as a kind of steady state data transmission mechanism as well. Obviously, we can do a lot of work on well, as I was saying, we can do lots of work on improving xenstore. Yay! Yeah. And I certainly applaud that, but it would be nice if we didn't have to use it any more than we need to. So yeah, it'd be nice to have a standard API for exporting stats without xenstore being on the data path. So use cases for this would be driver domain monitoring. You might pass your NICs through to a network driver domain. DOM0 doesn't have access to those NICs from then on, so if you wanted to, say, monitor network throughput from those NICs, you'd need something running in the guest to export those throughput values. So all those storage driver domains, lots of applications for that. Application monitoring, similarly, you're running a web server, you want to export stats from that. Now, if you're running a big Apache VM, you might want to install Nagios in it. But if it's something maybe more lightweight, so you have a microkernel or a driver domain which doesn't even have an IP address maybe, a lot of the standard solutions aren't going to apply. So it'd be nice to be able to use standards and APIs to be able to export this kind of data. So the RD daemon I've mentioned, when we first created it, it had a plugin protocol. So plugins would run in DOM0, and they would do a one-off registration over a Unix socket. They'd kind of give a standard identifier to the RD daemon. The RD daemon would send back a path in dev-vectium, and then the plugin would write its data to this path, and the RD daemon would read it. So there's this one-way data transmission over dev-vectium. There's no locking. I'll go into the protocol in a bit more detail later. But so this works, but the problem is we're using Unix sockets, we're using a file system, so these plugins are stuck in DOM0 at the moment. So to move them out of DOM0, there's a fairly simple analog. We keep xenstore in for the registration rather than doing it over a socket, and then we use the userspace grant tables for the actual data path. And I was excited to hear from David that this is completely broken. The userspace page table sharing.
Not completely broken.
Bit broken. It's
it's fine for what you do, probably.
yeah. So now we have plugins which can run in a guest. So the protocol, this was the original protocol. We had a kind of fixed hard-coded header string just so we could make sure that there wasn't complete rubbish in the shared file or the shared page. Then everything else was all kind of ASCII and human readable. So we had a ASCII hex length which took up 8 bytes, MD5 sum 32 bytes, and then a big blob of JSON at the end. So this would be the length of that JSON and the MD5 sum of that JSON. So the actual layout would look a bit like this. Can you see that okay? So we've got header, data length, data MD5 sum, and then this big blob of JSON. And the problem with this was that I've highlighted some of the fields here. So this data sources dictionary can change in length. So you may be exporting the one one kind of data point or multiple data points at the same time. So that can change, but generally we expect it to not change very often, certainly not on the kind of sample rate level. So we're sampling every few seconds. The set of data sources might change every few minutes or every few hours. So the problem here is we were passing all this JSON for every tick, even though we only want a small amount of the data in there, unless it's changed. So for a version 2 of this protocol, the idea is to pull the data we want to read every tick out from the metadata, move it up to the front end of the file, and then have everything in, well, as much as possible in binary fixed width data fields. So version 2 looks like this. We've got the same header as before. We now have 2 checksums, which are 32-bit CRCs, so down to 4 bytes for those. Got the number of data sources, timestamp, the data source values, which is interesting data, and then the metadata all sits at the end. So on the reading end of this protocol, the reader can check the metadata CRC, and if it hasn't changed from the last tick, it can basically ignore these last 2 rows, which are the nasty things they have to pass. So it can just go straight through and read a fixed number of bytes and get the useful data out. And this is what the data looks like on disk. Again, I've highlighted the things that need to be read every tick. So I've added all the new lines in white space just for readability. But yes, this is one dot per byte. As you can see, all the useful data is up at the start. And I don't have any nice graphs. I haven't really compared this scientifically, but it's a kind of hand-wavy number on the reading end, which is, I think, the important end, because that's where all the data is being aggregated. It's about a 10% speed up on the usual case where we're reading this like standard number of data sources. So I have a demo. So yeah. If this is still working. Was everything working earlier? No, it's not working. Sorry, my laptop crashed right before the start of this, and everything is
Should be 103.
a bit broken. No. Okay, I can work around this. It's basically a very simple page with a visitor counter on it, so this bit's not very exciting. So I have a very simple Python web server, and if I get okay, so we have got the home page. Now, so what this does, as well as serving at the page, is it dumps the visitor count for this page into a file in datasets.gem, just as a in64. So if I do that a few more times. So that's going up, but that's still on the guess. That's not very exciting yet. So what I've got here is a plugin, and if I go to this is running on a XenServer. So if I show you, this is the XE tool, which is the standard command line interface to most of XenServer's functionality, and I can run this command, which will show me all the data sources exported by the hosts. There's all kinds of things like CPU usage, I/O throughput for various storage repositories, memory usage, that's that. So if I run this plugin I have,
And the RD daemon is running separately from XAPI, right?
that's right, yep.
So process.
So this is chugging away. And what this has done is this should have created a new data source of here. And I can query what that is. So 4 visitors, not very good. So this does an interesting thing where even integer data sources, they get averaged over the tick, so that's why you, even though this is an integer, you get numbers like that. So it's now stabilized and it's now an integer again. And if I show you what's happened in xenstore, okay, so under the guest tree, there's a top level key called RID. So this is how it's advertised to the guest that this functionality is available in DOM0. So this is all written by the guest. It writes its identifier as a directory, and then under that it writes a list of grant references, it's only one in this case, and a choice of protocol, and finally a ready indicator, and that's what RRDD in DOM0 uses to decide that this plugin is now ready to go and it can now go and read the memory. So yes, so that's the registration, and then obviously the data is coming through a shared page. So if you're interested in this, the protocol implementation, so this is all written in OCaml. The protocol implementation is there. There's also a full front-end implementation, so that is the xenstore registration plus the actual data path. These slides are up there if you want to have a look. And that's about it. Are there any questions? Yes?
Is there a way to export this to the binary RD format so that you use Nagios and all of the existing monitoring things to?
Is there any way?
So you have the RD daemon. Is it actually storing it in the RD file format?
Yes, it is.
Oh, so it's fully interoperable with. Oh, cool. And then, so the interaction with XAPI is that it links to the same library, or does it?
So XAPI isn't doing very much. The registration kind of goes behind the scenes of XAPI, and then all XAPI is doing is servicing the XE request. And so these various daemons, RODD, NetworkD, XenOxD, are pretty much acting as slaves to XAPI. XAPI is still the host level hub. It's the only thing listening to the outside world. But when I run an XE command, XAPI is then deferring to RODD and actually getting the data source from there.
Right. So we can use the RD daemon with whatever interface it uses.
You could use it natively, yep. It's just HTTP over a Unix socket.
Cool, give that a try.
All right. Any other questions? All right, I'll finish up then.